Okay, let's review in Discovery Education what they have to say about the free body diagram. There it goes, didn't want to move for a second. How do physicists diagram the forces that affect the motion of an object? Physicists use free body diagrams to show all the forces acting on a single object. All forces are represented with arrows, since force is a vector quantity with magnitude and direction. All arrows for forces originate from the object's center point and extend in the direction of the force. If known, the length of the arrow can be used to represent the magnitudes of the force. What does it mean to be in equilibrium? An object is in equilibrium when the net force acting on the object is zero. Remember that the net force is determined by taking the vector sum of all the individual forces acting on the object. Objects at rest are in equilibrium since they have no acceleration and therefore no net force acting on them. Objects in motion at constant velocity are also in equilibrium since they have no acceleration and therefore no net force acting on them. How do physicists show that forces on two or more interacting objects? Well, let's see. Free body diagrams show the forces acting on a single object. Therefore, if two or more objects are interacting, then the object should be considered separately, and only the forces acting on a single object should be drawn for that object. In other words, you do it one object at a time. And here is an example of a car, a free body diagram for a car going around what is a banked, likely circular track where the force of gravity goes downward, otherwise known as the weight. The force of friction actually is pushing downward because the car wants to sort of rise up the track a little bit. Right, so I guess it could be banked even more. And the normal force is perpendicular to the surface, and because the surface is inclined, this normal force still points normal to the circle. Remember, normal means at right angles. So this normal force is still at right angles to the surface and is inclined to the weight. We're used to seeing them be opposite each other, but here, since the surface is inclined, the normal force is 2, but it's still at right angles to the surface. Okay, so there was a real live demonstration of a simulation with a free body diagram, and also a little bit about what Discovery Ed has to say about it. I hope that makes things clear. Okay.